Okay, so first and foremost, I apologize for the last video. The camera was in the waterproof housing, so the audio was quite terrible. Plus I'm a mumbler. So I figured I'll give you an overview of my setup here for the trolling motor. Having an issue with it where the lights aren't lighting up on here, the LED displays in any speed. And I got it through Amazon, so of course contacted Newport. Newport's like, oh, you bought it through Amazon, you got to go through them. And then you go to Amazon and it's the Newport store, but whatever. I have to make a decision. I got a couple days left because it's in that 30-day period and I've only used it twice, whether or not I want to send it back or not, or if they're going to give me any slack about me sending it back because I put a little yellow paint on here, or I cut the battery connections to attach to the battery. In any case, we're in full speed right now. According to this, we're pulling 2 amps off of my 100 amp hour battery, which, interesting enough, if I go to 4, 3, 2, 1, let's just see, off, really nothing, 0.6, 0.7, I don't know why I had that in there, sorry about that, but yeah, now even I can see it better now. 1, 2, 3, 4, 5. No lights. Same amount of amps. So, let me give you my setup. Motor, obviously going through its wire. Got a quick connect here for the battery going into a box. And then the battery's got a quick connect here so I can just take the battery out. I have a solar system back there, so if I use the solar system to charge the battery, yeah, free energy. In any case, what I wanted to do was put in a kill switch, which I did. So if I pull the kill switch, motor dies. Put in the kill switch, motor comes back to life. The kill switch was 12 volt switch rated for 5 volts. So obviously if the motor is pulling a certain amount of amps, and then I got these lights and everything else pulling amps, I didn't know if the kill switch would be able to handle that. So what we did was, give it a layout, got a waterproof battery box, added some of these, what's the appropriate terminology for them? Connectors, lines, they crimp down on the lines. Sorry, I had a glitch in the matrix called my head. Strain relief connectors. So the strain relief, basically it screws in and it tightens down to make the wires waterproof in case I get water on there. However, I was able to find on Amazon some strain reliefs that have a longer thread, because this box is kind of thick, and putting the regular relief in there, we don't have much threads left on the other side to put the strain reliefs on. So this one's falling off, but I gotta swap that to the longer ones. So here's the deal. I have a smaller battery in here. That's just for the lights, not for the motor, in case I just want to take the battery off and still have some lights on it. But essentially the motor is running into this 60 amp waterproof fuse, and obviously if we kill the fuse power, kill the motor power, fuse power back, we have motor power. So the main power is coming into the waterproof fuse. Main power is coming out of the waterproof fuse, and it's going into a 12 volt automotive relay. I believe that's a 60 amp relay. Actually no, it might be an 80 over 60. I think it's an 80 over 60 relay, double, depending if it's AC, DC, whatever. So the main power comes into the relay on the 30 circuit, which is the primary power circuit. The ground is the ground. The 87A outlet on here always has power, so right now that's just capped off somewhere in there, we're not using it. Then you have, like I said, your black wire going to your ground. White wire is also wired into the power coming into it, and what that allows it to do is it runs up to that circuit there, then it runs back from that circuit. Actually, I apologize, the main power coming in is tapped up to that circuit, then that circuit comes back and pops into the relay. So once I plug into the safety disconnect up there, That was just the amp meter telling me it's going to turn off. 2.14 amps. So once the power comes back there, it energizes the relay. Easiest thing to do is, here, we'll turn this off so you can kind of hear it clicking. So if we disconnect here, and then we do this pull, you'll hear the relay click, click, click. So as power comes up here, we close that circuit together. It sends power back to the relay, which transfers the power from the 30 over to the to the motor, to the 30. From the 30 to the 85, 86 to the 87. So from 30 to 87. So that's what the relay is doing. The relay is just there because it's using a less amount of power, and I don't have to worry about burning out the disconnect switch up there. Back on. Trying to see what our battery runs down in like an hour. And I had this out twice. The second time on the water the other day, it died. I had it in full gear, ran for maybe 30 seconds. I'll try and edit a clip in here real quick. But it died, and then when I opened this box, it was like this, and I kept hitting the reset, but there was nothing here. It was just really soft, so something in here got really hot. And like I said, that's power coming in, and the power is going out to the relay and out to the motor, but for some reason something in here got hot. And I do have 10 gauge cable going here, so I have 10 gauge coming in, 10 gauge going out, which is what comes with the motor. But I might switch these from the battery to here just to an 8 gauge, give it less resistance and more power, less heat. I don't know why this got hot, but I had to wait to be able to do that and reset it and throw it back on. But yeah, that's the initial breakdown. As far as the kayak itself, it's a Crosswater or Quest Crosswater. Got it at Dick's Sports. Eventually I just added these mounts here, 8 rivets, which are, actually I thought they were plastic rivets, but they're aluminum. Really nice strong rivets. Put them in both sides, and then I just made a piece of aluminum here that I cut, though I have 2 welders, didn't feel like welding it because I'm lazy like that, and just bolted it on. So it sits on the transom. The motor's on the transom. The transom gets mounted with its 4 bolts onto these 2 bars. Then these 2 bars actually lay onto the back. So most of the motor weight coming down here is just laying on the back portion here, which is pulling up on these bars, which are underneath. So it kind of lifts up here and gets bolted. And then that lifting up here is held down by these nuts, which are double nutted on here onto the bars. And then I just have in the back here, this bar originally I put here for steering in case I wanted to run another steering line or something like that and have pull steering going up to the neck. And I had the pull steering on there, but it was really heavy. I didn't like it at all. So for the squeezing disconnect to drop the motor, I have a automotive clamp there. And then what I did was, rather than just put the clamp totally around, we just drilled a little hole here. So we can adjust the tension for the steering still by loosening this, and it just goes through a hole right here in the clamp, but it holds the clamp close enough but not too close that this mount can't come down for the height adjustment. This was an extra piece I added on for the steering. This was a 1 1/8 split ring collar, and then I have this, which was an 8-inch eyelet in stainless steel, and then I just welded this onto here, drilled a little hole to kind of inset it, and then just welded it around there. And stole a broom handle from a new broom I have. That was 5-foot handle, which actually works pretty good because you can just push and pull from here, steer the motor. It's a lot lighter than trying to pull steer where you're pulling one line and adjusting the other line, because that was terrible. With the clamp pulled in like that, the motor's able just to go up and down freely. So when it's on, you're in drive, obviously it's pushing against the boat, so it's pushing, so you don't have any issues. But if you went to go in reverse, instead of the motor pushing, it's going to kind of pull the opposite way. The motor's going to want to do this. It's going to want to kind of lift upwards. But even in reverse, I can reach back and use this as the throttle to kind of extend the throttle. Even though it extends a little bit more, it's still a far reach. So I can still on and off, and I still have enough hand pressure where I can just kind of hold the motor up like this in reverse, and it holds the motor down, so I really don't have any issues with the motor bouncing. And by not having to deal with that lock there, what I did was essentially I have another collar here. I think that was a different size, so let me give you the right size. So yeah, this is a 1 1/4 split ring collar. So you have a 1 1/8 split ring collar here, and then a 1 1/4 split ring collar there. And that just pulls down to this little rope here, which is kind of got an adjustment, so when I pull the motor, it kind of pulls it to the side. But this is running down to a pulley, which is dangling here. I don't know why. Oh, because I took it off of here. Duh. And I just added these little eyelets in there. I took off these screws so I could reach in here to get to the bottom of this, because the only entry port I have for this is obviously the center cover right there. There's no other way for me to get my hand in there and put a bolt, so I ended up just taking these little fishing line things out, reaching in here, was able to get into there to install those bolts. But yeah, so I just have a pulley going there. Pulley runs up to another pulley in the front here. This is just a band to hold on to the pulley. And then I have this, which is a, can't think of the name either, one of these clamps. Yeah, take a picture and put it on Google. But yeah, I can just pull this from here. And the motor's kind of heavy, but the pulleys do help with the weight. But essentially when I pull here, this pulley's here. It's going to lift that pulley up there. And then you can see I can up and down. And then this line's a little thin for these. And this whole thing's going to roll back when I pull it now. Yeah, because I'm not mounted. But you get the idea. I pull here. If I put my weight on here, I can lift the motor up and down. But see how that bar is extended and it only goes down a certain distance? So that's why what usually happens is I run this line down through here, and then when I pull, the motor pulls kind of to the right, and then from there I'm able just to pull the motor down, 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 all the way down to here. And then height-wise, if you look at the bottom of the motor, the bottom of the kayak, it's high enough that I can kind of edge this more and really push it down, but it gets it out of the water where it's still higher than the bottom of the kayak, so I don't have any scraping issues. And then, you know, I just get into the water and release it. Now, like I said, these clamps aren't the best, so sometimes what I do is, after I pull it through here and I let it back, it's kind of grabbing, but I just give it a wrap like that and stick this in, and that holds it down long enough for me to get it out of the water without any issues. And then obviously for transportation, I just push it down. I put one of these clamps on here, like that, and that's it. I transport it. For the broomstick handle, that magical broomstick steering, this is just some Tessa tape on the end, that automotive tape, fabric tape. And then I took the regular handle, just cut the collar there, slid it into the eyelet. This is a shear pin from a snow thrower, with the little clip in there, so even if something were to really bang the motor and really jam the motor up, if something were to put a lot of force into here and my hand was on here, this shear pin is going to snap. That's my theory. Not that I expect anything to really bash this motor. However, I'm just showing you how I laid it out. So we have obviously these LED lights here, these strip lights that you clean and stick on. They work like crap, so I stuck them on, but eventually I went around them right here with silicone all the way around them, so now the silicone's actually holding them on there. Plus, if you come up to a dock or something, since these are right on the edge, this is most likely to take a hit. So, but yeah, silicone's on there, it's holding them really well. A little silicone going up to the wires. you know, joy to the world. We have our little all white light that can go up and down, and that's just mounted into the box right there. And I had this waterproof bag with the battery in it. This bag is way too big, so I'm gonna buy one of those cheaper dry bags. That should be coming today. And then what I'll do is I'll just keep the battery in that dry bag, fold it over. I'll just have these leads coming out, and then we'll see what kind of improvements come down to. But instead of having this kind of wire here, I ordered some of those photovoltaic leads or PV leads or MC4 connectors, same thing used on a solar system, because they could take higher amperage and they're thicker wires. But I believe what I'm going to do is I'm just going to use that MC4 cable here instead of having these, I think they're ASC, automotive service cables or whatever, more for automotive industry. Instead of having this kind of waterproof connector, which, you know, you push in and it should keep water out, those MC4 connectors, they're made for outside. So I mean, that's what we're using. Strain relief connectors. So this would be your standard size, and you twist that and it'll get smaller, in case you don't know about them. But you see how much thread's left once this back is on here? Like none. And then these are the extended thread strain leaves tightened down, so you can see the distance is quite remarkable. So this longer distance will be helpful to get through this box, which is probably like 1/4 of an inch thick, and obviously that's not really making it for 1/4 of an inch thickness, trying to get something onto there. Then this is the MC4 connectors that I'm talking about, and you know, a little bit more of a pain in the ass to get them off, because you got to squeeze that hook down and get your finger in there to get those separated. See if I can kind of do it by hand. Squeeze one, squeeze two. You get them separated, and then obviously that's more of a watertight connection with an O-ring there and there. So I'll probably swap those wires there from that ASC, that automotive service connection, for these MC4 connectors. I'll be able to just pop them in and have more of a waterproof seal with an O-ring up there. Plus generally they can handle a higher amperage, so I'm not worried about 8-gauge wire going in here, going up to that thermal fuse. But that's it. We'll persevere to make it slowly better, but right now it's working. There's different battery monitors for lithium batteries and regular. This is still claiming, I don't know how the light is there, if you can see that or not, claiming 13.2 volts and 100%. Although we've been running this motor at quote-unquote full speed for 45 minutes. So I'd imagine at 45 minutes it's still going to be relatively seeing less, but according to that, still at high speed, it's a little over 2 amps that it's pulling. Battery case, 78. It's about 72 degrees out here. 77 on top. Get my finger in there. Let's do this. 77, 78. So getting a temperature of 85 on the relay. And 75 on the waterproof. 76. Yeah, this ain't gonna work. 85. So maybe 85 degrees on the relay right now, which is 10 degrees above ambient temperature. Wouldn't see that as an issue. So anyway, that's the setup for my Quest $400 magical kayak from Dick's. And then right now it's just rolling on a little fucking, what do they call those? Those kids' little wagons that rotted out on top, so I still had the bottom, so I just stuck it on there. Thanks, Nadine. Anyway, that's my layout for what it's worth.